Hello everyone, I'm Kat. I'm a third year and I'm majoring in maths, and welcome to today's intermediate LaTeX workshop with the focus on typesetting technical equations. So today's workshop will run a little bit differently just because it's over video. If you've been to the intro one, we normally structure it as I will demonstrate a skill which you'll follow along with, and then I'll allocate some time for you to practice those skills and challenges. And there's also normally a break in between, but today I'll just demonstrate the skills, and then when it's time for the challenges, just feel free to pause so that you can have some time to practice before the answers are revealed. So without further ado, let's get onto today's workshop. I've just put up an example of what you can do in the end with LaTeX once you've got all these skills combined together. So in our first intro to LaTeX workshop, we just kind of got used to LaTeX, kind of the setting out, the formatting, and it just kind of gave us a taste of what it's like. Today, we're really going to delve into how we typeset the technical equations. And yeah, it's just a little bit more content about today's workshop. We're just going to focus on using math mode, and then we're going to make sure we've added all the appropriate packages into our LaTeX so that it can actually work properly. And the experience poll, but that's okay since it's just a video today. So what I will get you guys to do is to hop onto Overleaf. If you've been to the previous workshops, you should already have an Overleaf account, but if not, it's very easy to set up. All you do is you kind of just go onto Google, you Google Overleaf, it should be the first one that pops up. And with that, you should be able to just use your university account to use your university email to make an account, and it should give you Overleaf Premium for free. But even if you don't have a university email, it's okay. It just means that you won't be able to make as long of a document. But it shouldn't matter too much today since we're not going to be making that tediously large of a document. Okay, so to refresh us a little bit about the interface of LaTeX, this is sort of what this is what we'll be looking at when we first open up our Overleaf. For those that haven't started a project yet, you can just hit new project and then blank project. For the people that were in the first workshop, you might be looking at something like this, which is similar to what we left off with last time. But today I'm just going to use pretty much a blank document with some images inserted so that we can see like the goal, our end goal for typesetting, because I find that helps. But yeah, feel free to follow along, and a link to this, because I'll add some notes in here, a link to this document will be available after the lecture. Okay, so what is the first thing we're going to learn? So the first thing I wanted to talk about was packages for equations. We saw in the previous workshops that we needed to use graphics to insert images, and then I think we also needed to use maybe hyperrefs to insert hyperlinks. Just a bit of revision, what packages do is they allow you to extend the function of LaTeX. And for example, today we're going to use all of these AMS math packages. What they allow us to do is basically all these fancy symbols that you see here, like the limit and the sum. Without that, you can't really access these symbols. And also to access the environments that we need today, the math mode environments, we'll need those packages. So what we need to do is in I'll just delete that, either in the style sheet that we've created from last time, or from the preamble, which we discussed was everything before begin document. That. So today what we need is these packages. What I'll do is I'll put them in a link in the video description. So all we need to do from here is just copy and paste them into either our style sheet or our preamble. I'm going to leave it in the style sheet for now. And we'll just hit recompile just to make sure that our package or our compiler has read these packages. And the first math mode we're going to explore is inline math mode. So we'll be going over a few math modes today. There's inline, display, display align, equation tags, and we'll also look at an environment called cases. But starting off with the most simple is inline math mode. And we're just going to try and typeset this limit. So, and you can see I've got like an image of that limit there so that we can have like a visual as we typeset. So what is inline math mode? Inline math mode, as you'll come to see, is math mode is when you want to typeset mathematical equations that sit flush with the text. You'll see what I mean in a second. I'm just going to put some sample text. And then let's actually do the typesetting of the limit. Now, to access this math mode, you might have already seen it from the PowerPoint, but we need to either use like $ on either sides, or we use this like backslash parentheses. But I'm personally more of a $ person, and I think it's I think the other notation is actually a little bit more outdated, so I recommend using $. And in here we're just going to do \lim for the limit, and you see how they've got this like x approaches infinity sitting under the limit. So to access that subscript, we use an underscore character. And then we use curly braces as our grouping element. We can go x, and then that arrow is \maps to, and then infinity is \infinity. I'm just going to hit recompile so that we can have a look at this. Okay, so far we've got hello world and we've just got the limit x approaches infinity. Okay. And what you'll see here is that it's like flush with the text. So this is more for when you just want to like type something and then you just want to have a quick like equation in some text. Once again, every command is started with \. I'll give you a cheat sheet for all of these like different symbols like limit, sum, infinity. But for now, it's probably best to remember them just intuitively, because with LaTeX, half the time you can kind of guess what the command for, say, something like limit will be, because it's just \lim or \infinity without any vowels. But yes, now let's do f of x. Just hit recompile to see what that looks like. Okay. Now, as you can see, we have a slight like deviation from what our goal was to typeset. That like x approaches infinity is sitting like directly under the limit. That's because there's like a toggle on, toggle off like display option for inline math mode. Is that if you don't want this like equation to be perfectly flush with the text and you'd much rather like that display style, there's a command that you can use, \display mode. One moment. Okay, sorry. Oh, are we back? Okay, sorry about that. We are back. As I was saying, to toggle between the different display styles, we just have this command and it's just \. Trying to get my video on. Oh, there we go. Okay. Just to toggle between those two display styles is this command \display style. So let's have a look at that. And yeah, that's now perfectly in line with our goal. I'm just going to add some comments. So \. style between inline and display mode. Dollar signs start and end the inline mode environment. Oh, it'd be nice if I could spell environment. Okay, there we go. Now, let's have a look at the second math mode that we want to talk about. So we've got inline and now display math mode. So this is probably the more common math mode that you'll see in most like mathematical documents. Maybe I could find an example. Give it a little bit of time to load. Yeah, so in most of these documents, these are all written in display mode. As you can see, it's like not, it's like its own separate formatting. So the way we do this is with another environment. And this environment is structured similarly to the environment that we use to insert images. It has like the begin, the name of the environment, and the end, and the name of the environment. And our goal is just to typeset this summation here. So I'm going to head down here and go \begin. And the name of this environment is called equation. And if we click the autofill, it will do the end equation for us, which is handy. And to do the sum, \sum. Once again, to do the like subscript, it's an underscore. We can just go n equals 0 to access the power of the superscript. It's like the power character and \infinity. Just hit recompile to make sure things aren't going badly. Okay, so we've got the first bit of our equation. And then to do like a fraction, it's \frac. Takes 2 arguments instead of 1. You could probably guess it's the numerator and denominator. So we'll just go 1 and then n squared in the second argument. Just hit recompile, make sure it's all okay. Okay, cool. So we can see that this display mode has its own like little section on the paper. One thing you'll notice is that LaTeX will keep track of your equations for you. So you might have like 5 equations and there'll be like 1, 2, 3, 4, 5. What you can do is you can like reference them like within your document. So you can use this command \ref. Let's say this equation 1, and then I want to reference \ref, and then the name of our label, and then that will just pop up as equation 1 on our paper. And this will be dynamic. So like if this happens to be changed to equation 2 because you've popped like another equation before it, like it will automatically keep track of that, so you don't have to go back and forth between changing your cross-referencing. But if you don't want that like numbering, we can do a trick here by putting an asterisk after the equation. Just hit recompile to see what that does. So yeah, that gets rid of the numbering. This is pretty common actually, like the asterisk character tends to make things unnumbered in LaTeX. So I'll add a comment about that. Asterisk makes unnumbered. And then we'll just hit recompile. Alternately, if you want like a tag, but you don't want it to just be 1 or like 2, you can customize this by using this command \tag. And then I can now name this like summation. Ooh. And we'll hit recompile to have a look. Yeah, so I'll also add a note about that. So backslash tag can be used to customize Okay, so that is probably the two main math modes that people use. I reckon like if you just master those two, you should be able to typeset most things in LaTeX. But there are a few more, a bit more advanced environments that we're going to have to take a look at today. So if we go back onto the PowerPoint, the next math mode that we'll be looking at is called align mode. So what is align mode? Align mode is probably the best environment for supporting like multi-line equations, or if you want to have multiple equations but like align them as the name would suggest. So let's take a look. Okay, so what we're going to practice typesetting in align is just this f of x equals sine like 2 pi n and then the cos equation. So I'm going to head down into my section for align mode. And the way we do this is it's the same like structure because it's an environment. Begin. Okay. And then we can just like typeset the first line because there's not much going on. It's not that special. And then pi is backslash pi. That's how all the Greek letters are accessed, just like backslash and then the Greek letter, and then n. Okay, cool. And then I'll just go ahead and pop in the same thing before cos. We'll just hit recompile to have a look. Okay, so it's sort of worked, but we haven't, even though like on the left-hand side, we've coded it to be on a separate line, it hasn't compiled on a separate line. Why is this? So once again, LaTeX doesn't read like white spaces. You need to use markup commands to tell LaTeX to leave a line. And what is our new line character? Double backslash. So now we can hit recompile and hopefully it's looking a lot better. Now it's recognizing there's two equations, so we're getting 1 and 2. Another quick thing is if you want to align this differently, an ampersand, you can put an ampersand in every like line of your equation, and then what LaTeX will do is it like finds all the ampersands and kind of just brings them together. So that alignment doesn't look very nice. So I'm going to maybe put it in the same spot so we can have some nice symmetry. Okay. I'm just going to make a few quick notes about that. So double for new line ampersand for alignment character. Once again, you can customize the tags on this equation, but you have to make sure to put the tag, like the command backslash tag, before the double backslash new line. For some reason, otherwise it won't compile properly, probably because you're telling it to start a new line before doing the tag, and that doesn't quite make sense. So let's tag them. Hit recompile. Okay, and then once again, if you want to do unnumbered, you can pop in the asterisk. So that pretty much holds for most, like for most things that become numbered in LaTeX, you can have them unnumbered by just adding some asterisks. One thing that I did want to point out is if you have something like, let's just do the same environment, align. And then instead of typesetting 2 pi n, maybe we want to typeset like pi on 2 in the brackets instead. We can go frac /pi. Oh dear, there's a lot going on. I will just, I'll freeze. So f of x equals sine x / pi. What you'll see is these like the brackets aren't the right size, if that makes sense. Normally what you want is like the brackets to be completely over the fraction, and here it's not really, it's just like the normal sized bracket, like same as there. There is a trick that we have in LaTeX to make things dynamically sized. Dynamically sized being that it will adjust itself, is that you want to format it like this. You want to have, so find where your two brackets are and then put \left on the left bracket and then \right on the right bracket. And now let's have a look. So now it's like dynamically aligned, so it will like readjust itself to fit the size of whatever you're like bracketing it around. And this works for most things in LaTeX. So you can also do this for curly braces, like a modulus, like absolute value, square brackets, anything that could start and end something, you can dynamically adjust them by using \left and \right. So dynamically adjust the brackets with \. And that will be a hint for the challenge that is coming up later, because I think, yeah, you'll need to be able to learn how to do a dynamically adjusted bracket. So those three environments are probably the main environments that you'll use. There is one more environment that I wanted to talk about, but it's like a little bit different. It's actually like a nest environment inside of another environment. You'll see what I mean in a second. There's the dynamically adjusted brackets, but we've already done that. Say you want to do a piecewise function. Okay. So this is an environment called cases, and what's special about it is you can only access it inside of another math environment. So I've picked this one to introduce you guys to the idea of like nested environments inside of other environments. So to typeset something like a piecewise function or like an indicator function here, we first need to access any sort of math mode. Any sort of display math mode, so either a line or equation. I'm going to do equation since, actually, maybe I'll do a line. We might end up typesetting more. I think a good trick is that if you don't know whether it's going to be a multi-line equation or a single line equation, just do a line anyways, because it supports a single line equation as well, so it just covers all your bases. Okay, let's do f of x, which is easy enough, equals sorry about that small little internet cutout. But as I was saying, we first do f of x, and then let's actually do the cases environment. So we set this up the exact same way that we set up every environment, \begin. And the name is cases. Okay, I might do like a line there just so it looks nicer. A good tip is whenever you're doing something that's nested inside of something else is to like leave an indentation. It's like good practice because when you look at it, it's visually easier to understand what's going on. So yeah, begin cases, and then we have 0, and then that's like element character, but it's \in a double backslash for a new line, 1, And then to do this like not in, this is what you do is you put like /not and then in. So what not does is it will put a slash through the next, like the following character. So not in a, and let's hit recompile. Where is up? There it is. Yeah, so perfectly matches our target. Yeah, so this is just meant to introduce you to the idea of like math environments nested inside of math environments. Because if you go on to typeset more complicated stuff, this is something that comes up a little bit. Okay, now I bring us to our first challenge. But before I present our first challenge, I'm just going to point out that we have a cheat sheet, and I think I talked about it before as well. There we go. So this cheat sheet was made by Miriam, who was the LaTex instructor before me. So all credits to her. What I might do is I'll copy and paste this and put it into the document so that when you guys have access to it, you can click on the link and follow it that way. I'll just put it here. And I'll just point out where most of the stuff that we're doing today is. There's the math mode section. So we've already seen the majority of these commands, I think. Maybe not square root product we haven't seen, I guess. But most of these, I think we've had some practice with. Yeah, so let me introduce the challenge. There we go. Current slide. Okay, so there's two like variations to this challenge. You can choose which one you do. This is the bottom one is like the challenge, and the first one is kind of just like a skill check. So yeah, can you typeset the following and use the cheat sheet if needed, and remember the dynamically aligned brackets. So I'll give you some time to pause, but what I'll do now is I will reveal the answers. So let's do the first one. And I'll do it in challenge time. Oh, I wonder why my image isn't going in the right spot. I'll just make it smaller so it hopefully, there we go. Okay, so this is our goal. So let's do the first one. Let's just pop it into equation. And I'm gonna pick the asterisk one because there's no tag, so I don't want a tag. To do sign, there's like two ways to do it. You can either go just like sign and type it out, or you can go \sign. There's a very little difference, so I'll just use \sign. To do the dynamically aligned brackets, we have to go \left, left bracket, \right, right bracket, and then in the middle of that, we need to use the fraction commands, pi on the top on the numerator, and then 3 on the denominator. And we're just letting this equal square root of 3, which is squirt 3 on 2. And we can hit recompile. Yeah, so that's pretty accurate to the goal that we were trying to typeset. One thing that I will point out is that I think on the cheat sheet, you'll see that the square root function is accessed. Yeah, the square root function that is taking two commands, like you can see there's a square bracket and then an X. So what the square bracket means there is square brackets actually denote a optional argument. So what that's saying there is that we can either include a command for that or not. If we don't include a command for that, the default is just root 2, as you'd expect. So that's why we haven't had a second argument. But yeah, just a little thing to keep in mind is that if you see any of these commands with a square bracket, it basically means it's optional. Whereas I'm sure you've noticed by now, anything in those curly brackets, you need to put something there. Otherwise, you'll probably get an error or some issues with your compiler. One thing that I wanted to note was if you ever type, like LaTeX has this feature, I guess, where if you want to type pi, actually I should put this in math mode. If you want to type pi and then you want capital pi, the way you access that is just by going and changing the sign of the first letter, as you can see there. This is like quite a common trend in LaTeX. So yeah, LaTeX is case sensitive. I'll just jot that down as a note. Actually, we can use logo command for LaTeX, but LaTeX is just hit recompile. Oh, I'll leave a new line so it looks a bit neater. Okay. Oh, that's a little messy. Maybe I'll just go leave some space. Okay. Now, okay, so normally now we would have a little bit of a break, but since it's a video, but since it's a video, there is no break. But the next thing that I wanted to talk about after the break, is just like a few tips and tricks about using LaTeX. The first thing was Detexify. This is like a really great tool because I'm sure, as you've noticed, that those like commands are kind of hard to remember sometimes, even with the cheat sheet. So this is like a really good hack if you need yeah, so what this does is like you can draw the symbol that you want, and what it will do is it will come back with the command and then whatever package is needed, and what environment supports it if there's a special environment. So let's just try something like small, greater than or equal to, oh God, I've drawn it so badly, but now it's telling you this is the code. You need to put it in math mode. And you need to make sure you have the AMS symbol, which we should already have installed. Let's try maybe a heart. Yes, a heart suit. Heart. Oh, I didn't even know. Anyways, so that's a good little handy tool. Another few handy tips and tricks is that a lot of things are encoded in LaTeX. So if you're ever like online and you see like an equation from an article, chances are that is going to be written in LaTeX. So for example, Wikipedia. So Wikipedia encodes all of its technical equations with LaTeX. So search up maybe Green's theorem. And then, yeah, so say you want to put this in your document instead of just typing it all, because that looks like a drag. Copy and paste it. Start a new section. And then we just need to put it into math mode. I've copy and pasted some of the, if you get this weird stuff, it just means you've accidentally highlighted some of the text, and the text isn't supported in LaTeX. It's just I'll take out the display style as well. It's just the mathematical typesetting. So hopefully that gives us, Green's theorem. Another common one is Desmos, which I already have up for some reason. Oh, there's nothing here. Desmos normal equation. So yeah, we can just copy and paste this straight into, does that even copy and paste? Hopefully. We can put this straight into our document. Another one is Mathematica, which I won't bother booting up, but there is a option for supporting LaTeX in Mathematica as well. Off the top of my head, those seem to be the main few. So yeah, could probably potentially save you some time with just transferring between documents. Now, just the last bit of content before we wrap up. So what's really great about LaTeX is you can kind of make these custom commands. You can call them shortcuts or macros. What we can do is, if you ever think that some command in LaTeX is a bit too long, a bit too hard to remember, what we can do is you can write a shortcut. So we can either do this in the preamble, maybe here, or we can do this in our style sheet. I'm going to put it in my style sheet for today. Oh, there are some spoilers in here. Let's delete that. So do you remember when we had the dynamically aligned brackets, and to access that we needed to go like backslash left bracket, backslash right bracket. So there's a whole lot going on there. Let's write a shortcut for it. So backslash new command. So this is how we write macros. And the first curly bracket there, that is just going to be the name of our new command. So maybe I like to call it like paren, because it's like parentheses. Maybe like the shorter the better, I reckon. In this square bracket, as you can see, square brackets are optional. That's because not all of your shortcuts are going to take an argument, but what we just put in the square bracket is we denote how many arguments our command takes. So if you think about backslash frac, which took 2, we would put 2 here, but because the brackets are just like enclosing one like sort of thing, we'll just put 1. And now this third bracket is where we actually like do the coding. So this is where you put like the backslash left, backslash right. And then to tell LaTeX where our argument goes, we put #1. So we're just going to say it's going to sit in the middle of those 2 brackets. And we'll just hit recompile. Nothing should happen though. Okay, cool. Let's use our macro. So what I'll do is I'll make a new section. Macros/shortcuts. Just hit recompile. Okay, so I'm going to go begin. I'll do it in a line mode so we can compare like the macro version and then like the long version. Let's go frac. Oh no. Oh yeah, let's go frac. Backslash pi on 2, backslash left. So this is the one we're going to do without our macro. And then I'm going to copy and paste this like fraction because I'm lazy. Backslash paren is what I think we called it. And then just put that in there. Oh, that's a bit big. Maybe we should move. Oh, I don't know why I put a random bracket there. There we go. Let's hit recompile. And as you can see, those 2 are identical. Another good one I would recommend is if you go into style sheet. pfrac. So it's like a fraction and a dynamically aligned bracket all in one. So the way we do this is you go, we'll just change the name to pfrac. And then here we need to put a frac inside here. And now it's going to take 2 arguments instead of 1. We can put hashtag 1, hashtag 2 for the denominator. And we'll just hit recompile. And let's check this out. So backslash pfrac is what we need. Put pi in the first argument. Denominator. We'll have a look at that. Okay, cool. So we can see that these are all producing the same thing, but the lines of code, well, the length of the code is getting significantly shorter. So I guess this just demonstrates with how you can like really customize your LaTeX use. And then it's, yeah, you can really make it, like the end goal is to make it as fast as handwriting, right? But yeah, you can really make it quite fast if you have a lot of macros written in. What I will show you is, I'll show you all the macros that I've got. I don't have that many, but they definitely make life a lot easier. Bring up the stochastics assignment again. As you can see, a lot of packages and a lot of macros. They definitely save a lot of time. I think I had a few more macro ideas. Just some other common ones that come up. Yeah, pfrac we've already looked at. Big O notation. One thing I will mention is I've lost my document. If you want to access something like, if you want to typeset something like R in reals, or like Z for integers, you need to use /mathcal. R. Maybe it's not mathcal. Maybe it's mathbb. Let's see. It's been a while since I've done this because I have a macro for it. Yeah, it's mathbb. I'm not sure what BB stands for, but that is quite long. So what I would always recommend having macroed is /new command. And this is a case of like where you don't actually need to have like an argument in the square bracket. I always rename it to /r and then mathbb. And I basically go in and do this for every like subset, every set of numbers, sorry. So this is Z of integers, maybe Q for rational. So yeah, let's look at that now. By just using /r. Yeah, as you can see, same thing, but one takes a lot less time. Okay. Okay, so, oh, and sorry, one last thing is there are some special characters in LaTeX that are reserved, right? For example, /, we can't really like, if we put a / somewhere, LaTeX is just going to read it as a command. Another one of these characters is the curly brackets. Whenever we put curly brackets somewhere, LaTeX just thinks you're trying to code. So the way we get around this is we use / again. I'll show you what I mean. So to actually get a / character, it's //. It's a little weird, but and there it is. It's a little /. How to actually type. And then you might be wondering, oh no, I think this actually should be in math code from memory. Yeah, okay. And then how to actually do the curly brackets is we need / first bracket, / the second bracket. Yeah. So how to actually use curly brackets. Use the reserved characters by backslashing. Okay. And I guess that leaves us with a little bit of a hint as to our next challenge and our final challenge. So our final challenge is just, can you make a shortcut for macroing? Sorry, can you make a macro for this like curly brackets, a dynamically aligned curly bracket that is? So there's two main things to keep in mind here. One of them is, how do we actually make them dynamically aligned? It was like the backslash left, backslash right thing. And then we also need to keep in mind that the curly brackets are a reserved character, so we have to do another backslash. So I'll just show the solution now. Let's go new command. And I like to call this like braces, or maybe set. I'll go braces. That's what I usually call them. We just need one argument. Okay. So first backslash left, and then backslash again. So yeah, there's quite a bit going on here. Oh, is that was the answer? I'll have to delete that. No one saw anything. And then backslash right, and then backslash again. So I guess this, I promise, is as complicated as it gets, because it's like two special cases where it's like both a reserved character and you need to dynamically adjust it. But you normally won't see two backslashes in a single like line of code. We'll just hit recompile, and then let's try braces macro. And I'll go a line so we can have a space. What's something that we would have? Maybe like we'll just do the set of natural numbers. 1, 2, 3. To do like dots, you can either do C dots, or you can do dots. I like doing C dots. It just means centered dots. They just look a bit nicer. Then you do left. Then again, okay, there's a lot of lines of code there. Oh dear, why is it not happy? Oh my gosh, sorry. That's embarrassing. Left and right. Oh my gosh. Okay. Now that I've fixed my right and left directions, let's have a look at this one. Yeah, so there they are, just working quite fine. I'm gonna double check I haven't, yeah, that left and right is in order. It was just okay. And now let's do I think we called it braces. And then I'm just gonna copy and paste the bit in the middle. Oh dear, what has happened? Style sheet. Oh, my bad. I haven't put this in the style sheet for some reason. Anyways, let's recompile that, and then hopefully, yeah, that is pretty much identical, I want to say. So I guess if there are other macro ideas, those seem to be the first ones that come to mind. Normally there's also a little quick review quiz type thing, but we'll skip that today. There is a feedback poll. I'll maybe include this in the document, so if you want to leave some feedback, you're welcome to. Let me just add it in under here. section. That red dot means unsupported character, by the way. I'm not sure what it was, and actually, it's probably just some rogue thing that I copied over. Yeah, so that was all the content that I really had for today. Thank you very much for watching. If you have any questions, feel free to email me. I'll put my email on this as well. But eek. Oh, don't put it at the end of the end document. Yeah, but thank you very much for coming. And if you have any questions, feel free to shoot me an email. But yeah, that's all that we had planned for today. I hope it wasn't too fast or too overwhelming. But yeah. Okay.